We've looked at numbers in the past, and now we're going to come back to them. And besides just talking about positive numbers, we're going to look at how we deal with negative numbers. So let's do a quick little review. When we're talking about positive numbers, we discussed having weights. So here I have a 4-bit number. That 4-bit number, if we look at this, is 010. And with that 0101, we set up that all of these bits have a certain amount of weight to them. Starting at the least significant bit, we have a weight of 1, a weight of 2, a weight of 4, a weight of 8. And as we try to figure out what number this is 1 times 1, 0 times 2, 1 times 4, and a 0 times 8. So then we look at this number and we say, okay, it is 4 plus 1. Well, that gives us the number 5. And since everything we have done has only been positive numbers, we can say, okay, that's a positive 5. And this can extend to any number of bits that we have. We can go from 4 bits to 5 bits. And then when we add that extra bit, it's adding a weight of 16. If we go to 6 bits, we add an extra weight of 32. And that's the way that we work with these numbers. Now, all of this was dealing with just positive numbers. And we're going to have a name for just talking about positive only. The name we have is called unsigned. And unsigned, whenever you hear that a phrase, it's always going to respond to just dealing with positive numbers. If you have done any type of C programming code, you might have seen that you can declare a variable as being unsigned. And when you do that, you're saying all you're going to do is use positive numbers. Now, for all of these positive numbers, an important thing to remember is that we have a range of values that we're able to support. So for 3-bit number, the range we're able to support is 0, 1, 2, 3, 4, 5, 6, and 7. So our range was 0 to 7. And we can formulate a formula to figure out what our range of numbers will be. So for any n-bit numbers, we can take that n and we can substitute it in and unsign. Our range is 0, anything equal to that or greater than, and then less than or equal to 2 to the n minus 1. So for example, if we want to do 4-bit numbers written down here, we're going to go 0, 1, 2, 3, all the way to 13, 14, 15. Well, it is 0 to x less than equal to 2 to the 4 minus 1. 2 to the 4 ends up being 16 minus 1. Well, that is 15. And we saw that's where we ended our range. So now that we have positive numbers, we know that based off of our math that we done in high school, middle school, we know that there's an idea of having negative numbers. Well, negative numbers, when we add them in, it's not likely that we have just only negative numbers. It's very common that we can have applications where all we have are positive. It's very seldom that we can have just negative numbers. So most of the time we end up using the term signed numbers, and signed numbers means that we're going to have both a positive values and negative values. Now, it is important to know that once we start talking about binary, when we discuss binary, there's going to be 3 ways of how we can deal with signed numbers. Each of these 3 ways can be used in a number of different applications. It's not one way to say only one form is best. There are 3 valid ways of how we can deal with signed numbers. Now, the first way we're going to look at treating signed numbers is we're going to go back to the math that we're used to every day. Let's look at decimal sign numbers. And the way decimal sign numbers are dealt with, they use an option called sign magnitude, where if we have a number, say 32, we know that 32, that is the magnitude piece. We have 32 of a value, and then we're going to have a sign piece to it. So it's a positive 32. Or we could have a negative 3. We have this number broken up into 2 pieces. So that is just recapping what I said. We can have negative, we can have positive. We have magnitude pieces, a 3 with a sign, a magnitude 5 with a sign. And this is the way that we're able to treat all of these decimal numbers that we deal with on an everyday basis. So the one thing we can do is we could say, that's what I want to do with binary. Let's have our binary have a one-to-one representation with our decimal numbers. So if we do that and we say, you know what, let's have binary numbers that cover the range of -7 to 7. When we start looking at this, let's break it down into pieces. Well, if I have a binary values, I'm going to take it and have one piece be the sign and one piece be the magnitude. So if I'm going to look at just the magnitude piece, I'm looking at negative numbers are mirrored. So if I go from 0 to 7, I'm going to cover everything positive magnitude and negative magnitude. So I'm going to need 3 bits in order to do that. In order to handle the sign, whether it's a -1 or a +1, I'll require 1 bit in order to do that. So here, to say I want the range of -7 to 7, it ends up being an actual 4-bit number. But that 4-bit number is broken down into 3 different pieces. It's broken down into a 3-bit magnitude piece, and this magnitude can still keep the same weights that we've been dealing with. And then it's going to have a sign piece. How we're going to handle the sign is, if that sign bit is a 0, we're going to treat it as a positive number. If that sign bit is a 1, we're going to treat it as a negative number. So let's say we have -5. How are we going to find -5? Well, the first thing we're going to do is first we find the magnitude. I know I'm looking for the number 5. I figure out what are the weights I need to. That was that example problem we started off with. That is 101. I'm adding the weight of 4. I'm adding the weight of 1. That gives me the final total of 5. Now, in here, I want it negative. So to do that negative, we said negative was going to be a 1. So that top bit I'm putting in as a 1. So it is 1101. That is the 4-bit number for sign -5. Now, when we do sign and magnitude, it's easy for us to understand that because that's all the numbers we use every single day. But we really don't look at how we do our thought process. You know, as a human, we're able to keep track of a lot of different numbers. And when we're going to put something into a computer, we're going to build a chip on it. We want to try to have a very straightforward, simple method. And the problem that we kind of have with sign magnitude is when we're going to start looking at doing mathematical operations, sign magnitude with math kind of takes extra steps. Now, let's just say we're going to start off with something here with addition and subtraction. And I want to do -5 plus 2. Now, when we do this, a lot of us don't do this as the operation as it is written. You know, we hadn't been really taught on how to do addition with negative numbers. Well, we were always taught, starting off at elementary school, is we had 2 operations. We had an addition operation and we had a subtraction operation. And most of us, we will see this, and instead of viewing it as being an addition problem, we take it as being, I have a negative number, that's a subtraction. And what we really do instead is we flip that to say, the way I'm going to solve it is I'm going to do 5 minus 2, because I know that's the operation that's occurring. I'm going to get the result of 3. And then going back and looking at my signs, when I see the sign, I'm going to pick which sign I should be using. How do I know which sign I'm going to be using? I look at what has the most magnitude. In this example, it was -5. So that -5, that's the item I'm using. I'm using -3. So instead, if we had 5 plus 5, a +5 plus a -2, well, we do this as being 5 minus 2. I get a 3. How do I know which sign I'm keeping? I'm keeping the sign of whatever had the highest magnitude. So here it's going to be a +3. All right, let's look at multiplication. Let's say here I want to do -3 with a +2, and I want to multiply them together. Again, when we start doing our math from when we learned in elementary school, middle school, high school, we didn't do it as being negative numbers and positive numbers. We always did it as we multiply the magnitudes together. So I take 3, I take 2, I multiply them, I know I have 6. But how do we determine the sign? Well, we always had 3 different cases that we used to kind of figure out what the sign was going to be. If I had a negative times a negative, I knew my result was positive. If I had a positive times a positive, I knew my result was positive. If I had one negative number times one positive number, then I knew my result was going to be negative. So if we go back and we look at this, negative 3 times a positive 2, I know my sign needs to be negative. Well, all of these operations in our mind happen so fast because we've been doing this for so many years. We do it without even really thinking about it. But when I want to produce this as a circuit, you can see that there's a lot of moving parts. The moving parts are when I see addition and subtraction, I'm looking to see how to deal with that with just the magnitude, and then we'll handle the sign later. When I do multiplication, again, we handle just the magnitude parts, and then we do the sign as a separate part. So this was one way we could do sign numbers. And like I said, there's 3 ways. We're going to look at 2 other ways. Those 2 other ways might be a little bit more difficult to us imagining what the number means, but it makes those addition, those multiplication, all the math operations occur a little bit easier. So that's how we do sign magnitude. And next, we'll look at what is called one's complement.